Hi, I am Anjana Sharma from Telcoma Technologies. So I am here to provide you basic concepts of LTE fundamentals. So let's understand what is there in fourth generation and how 4G evolved. 4G, that means fourth generation, which has a major aim of high throughput, or I can say it has main aim of high data rates. As the proposed aim of 4G network is 1 gigabit per second for stationary users and 100 Mbps for high mobility users. So we have aim of 1 gigabit per second and 100 Mbps for stationary as well as for high mobility users. So that means fourth generation is evolved because of the requirement of high data rates. So that means what is there in 4G LTE network which has given us this much speed. So 4G network is evolved with the concept of fully packet switched. That means they want their architecture should be fully packet switched. Now packet switch, it means that there is no concept of circuit switching as we have in 3G and 2G cellular systems. So packet switch fully IP and packet switched network. Now what are the changes? So basic architecture is always divided into two parts. Basic architecture is always divided into two parts. The first one is radio network and the next one is core network. We want fully packet switched network. That's why it means that we have to evolve a new architecture with its own radio network and its core network. So that means evolution of a new architecture is there in our 4G networks. So that evolution of new architecture is SAE, which is known as System Architecture Evolution. Now in system architecture evolution, which is the evolution of architecture of 4G network. Now we are not upgrading our 2G and 3G network architecture. So we are evolving a new system architecture, and that evolution of new system architecture is system architecture evolution, which is there in my 4G networks. So as our requirement is high mobility, so network nodes should be less. And architecture, it is a requirement that if you want high mobility, so your architecture should be simple. And number of nodes should be less and faster. That means we want my architecture should be simple and number of nodes should be less. So we need to organize all nodes and all entities which are required for packet switching in a smart way. So what we have to we want one radio network which is EUT-RAN part. EUT-RAN is evolved universal terrestrial radio access network. Now I have written here evolved with UT-RAN, as UT-RAN part is there in our 3G cellular systems, but this RAN part is evolved as compared to 3G. That's why evolved. Everything is evolved. So we have written here a word E, evolved universal terrestrial radio access network. Now this EUT-RAN part is a RAN part or radio access network of 4G cellular systems. Now it should be connected to a core network. It should be connected to a core network. So, and here is my UE. UE as user equipment. So I will write here EUE, and this EUE is the evolved user equipment, which is the LTE handset. So EUE is connected to EUT RAN part, and EUT RAN part is again connected to the core network. Now, whenever we are evolving from 2G to 3G cellular system. So in 3G, we have changed the RAN part, but we have not changed the core network. As 3G is again circuit switched and packet switched. But in 4G, our requirement is only packet switching, only data rate. So we have evolved a new core, and that new core is EPC, which is again evolved packet core. Packet, core network and evolved. So that means we have a new core network in 4G cellular system and new RAN part in 4G. We are not using any 2G and 3G part, or we are not upgrading for 4G cellular system. Every architecture node and every entity is evolved and new one. That's why system architecture evolution. Now let's understand the various nodes in the architecture. So this is my EUT RAN part. We have number of EUEs attached to it. So that means with the help of radio interface or air interface, I am connected to EUT RAN part. Now in 3G or 2G cellular system, in RAN part, we have BTS and BSC. Simultaneously, we have Node B and RNC. That means handover decisions, and all decisions is there with RNC. But in order to reduce the latency of handovers, that means a handover should not take much time for handover decisions. So that's why, because our main aim is high mobility. So our handover should be faster. So in order to have faster handover, all the controlling of handover decisions and power measurement is there with only one node. So that is why we have removed RNC from our 4G networks. So in EUT RAN part, we have only one entities, and these entities are not connected to any controller in the radio access part like RNC. So the only network is E node B. So we have a radio access controller, but only one. E node B, evolved node B. Node B is there in our 3G cellular system. Now we have evolved new one node B, and that new node B is E node B. Now E node B is capable, is smarter enough to take decision by its own. So it do not have to take permission from any radio network controller. It is itself serve as a radio network controller for its users. Now we require that this EUT RAN needs to be connected to the EPC. So this is the EPC. Now this EPC is fully IPly connected. That means this is fully packet switched network. But we have various entities in EPC, and the various entities, the very first is MME. Next one is HSS. Then we have serving gateway, PDN gateway, and this is connected to PDN. Now what are these entities? MME is mobility, management, equipment. MME is mobility management equipment. Then we have HSS as home station subsystem. SGW as serving gateway. PGW is PDN gateway, where PDN is public data network. So that means my core network has basic 4 databases attached. So E node B, that means in the radio access network, has to contact to EPC. So it is connected. Every E node B is connected to MME and serving gateway. And serving gateway is again connected to page gateway and PDN. So E node B will communicate to MME also, and this will communicate to serving gateway also. Dotted one line shows that E node B will contact with MME for signaling procedures, and bold line, that means it has to contact serving gateway for data. So simultaneously so it will communicate to MME for signaling and for data to the serving gateway. Now what is the function of MME? MME is mobility management equipment. So MME is there for all authentication procedures, that means my security purpose. It is there for my location updation and authentication procedure. That is all issues related to mobility is there with MME. Whenever user are moving, so it has a continuous tracking area update. So tracking area update is there in MME. Now we require a permanent database for each and every subscriber. Its function is same as that of HLR. So HSS, we require a permanent database of each and every user. So permanent database is there in HSS, in which HSS is stored each and every information which is related to the user. That means its confidential numbers, like IMSA number, it is stored according to the location. Now MME can contact HSS if it wants to have a location of a particular user. Now we require data. So we have a public data network here. That means PDN. So we have servers here at this end. Now this main controller of data is serving gateway. Like we have SGSN in 3G system. Now this serving gateway is connected to PDN with the help of PDN gateway. Paging gateway is providing a gateway to the external network. We want to have data, so this will be routed to through serving gateway. Now serving gateway can contact MME also, because these are interconnection with one another in the EPC. So data will be routed from PDN to paging gateway or PDN gateway to serving gateway, and then serving gateway will forward it to E node. That means we have 1, 2, 3, 4 nodes in between, and I get a data. So this is a more simpler architecture as only packet switched network. We have not used the concept of circuit switching here in this. Packet switch architecture with no radio network controller. That means we have removed a one node in between. Now coming about the handovers. As a main requirement is high mobility. That means user is moving. User is moving, so it requires faster handovers. Now the faster handover decision is there with E node B. Now E node B knows where to give a handover, and E node B will give a handover. After giving handover, E node B has to inform MME, because MME is there for location updation. So UE wants a handover, E node B will give a handover, and after that it will inform MME that I have given a handover in a particular duration to this particular user. That means you have given the handover when EUE requires that handover. After that, you are informing MME. Now, this case is not there in 2G and 3G cellular system, in which node B has to take permission from RNC, because RNC has a database of each and every neighbors particular to that node B. So for higher mobility, so handover decision is there with E node B. What if neighbors are not defined in this? So in that case is required to contact MME. I can say that for signaling procedures, I require to contact my MME and HSS, and for data procedures, I require to contact these databases. I means user equipment through E node B. Now, E node B for handover. As I told you that it can give a handover to different or other E node B. So there should be an interface between two E node Bs. Now, the interface between two E node Bs is X2 interface. That means two E node Bs are connected to one another with the help of X2 interface. Now, interface between EUT-RAN and EPC. That means we require an interface between my radio access network and my EPC or evolved packet code. So this interface is commonly as S1 interface, but for signaling we have S1C, where C is for U control plane, and this one as S1U, where U is for UA plane. So simultaneously signaling and simultaneously data transmission is there in 4G networks. That means simple architecture, faster handover, which is the requirement of my 4G networks. So this is the basic architecture of LTE 4G that we had discussed. Thank you so much.